Okay, pause your video and try this question on genetic engineering. All right, a eukaryotic macromolecule, doesn't matter if it's eukaryotic or um, not. This is probably referring to human protein. Well, how do I know it's a protein? So the keystones will often, instead of just saying protein or lipid or carbohydrate or nucleic acid, those are your four macromolecules, by the way. They'll describe it in a less direct fashion, and so that's one of the challenges to this test. All right, but macromolecule just means protein, not all the time, but here it does. How do we know this? Well, it says a gene codes for it. So genes are sections of DNA that have information to make proteins. That's how I know. All right, so a gene can only code for proteins, not carbohydrates or lipids or other nucleic acids. That's how I know macromolecule refers to proteins. And that's how you want to know as well. All right, anyway, that protein, let's just say this is human now, that human protein can be made by bacteria. So this is known as gene splicing. Okay, so that's when you take a gene, so this blue DNA here is a human gene or human DNA, let's say. So there, let's say that is a desired gene. Okay, we want whatever protein that gene makes or has information to make. So we can cut that out using enzymes, okay, and we can insert that into the DNA of a bacteria. So let's say, and specifically the plasmid, which is a circular DNA. All right, so we can cut that um, and put that human gene, that eukaryotic gene, into bacteria. So now that bacteria, right? Now that do this, keep this in red. All right, now that bacteria has that human gene right there. All right, so when that bacteria does transcription and translation, it's going to make the protein. All right, it's going to make that human protein because now it has that human gene. Okay, and so why would this be useful? Why would this be useful is what it's asking. All right, let's go through the choices. Selective breeding is not an example of genetic engineering. That's just when you take, let me do this in green looks like go, right? Correct? No. All right, so selective breeding is not the correct answer because that's when you are selecting traits that are desirable and you're breeding for that trait. Like a dog that can run fast with a dog that can has superior sense, smelling. You might want to breed them together to get like a hunting dog or something like that. All right, so B, you could do this in the plants, like we used an example in our class, BT corn, to resist pests. But B is not the correct answer because you wouldn't. Why would you put this gene in the bacteria? You would do that because bacteria reproduce fast, and you're looking to collect that protein. If you wanted to affect a crop, you would insert that gene directly into that crop, like corn. You wouldn't put it in the bacteria, if that makes sense. Okay, so B is not correct because the problem says you're inserting it in the bacteria, and if you wanted to affect the crop, you would put that gene instead into that crop, not bacteria. All right, so B is not the correct answer. Forensics, that's not the answer either. The only answer related to forensics will be PCR, or polymerase chain reaction. That's making copies of DNA. All right, answer is D, mass produce. That means make a lot of human proteins, right? Humans, um, bacteria reproduce fast, and so do other organisms. So if you want to mass produce this desired protein, such as insulin is made this way, you would use this technique called gene splicing. All right, so let me show you one more example. Vaccines can also be made this way. All right, so here's a virus that could cause harm to people. So before you are infected with this virus, you can take a gene from that virus, and that gene will make a protein um, that is foreign to the human, right? So we can take that gene, insert it into the plasmid of a bacteria, and you can put it back into the bacteria or you can put it into a yeast cell. Either way, they're going to reproduce very fast. All right, so now this yeast cell or bacteria cell has that gene. It's going to mass produce that hepatitis, in this case, hepatitis protein. All right, so that's known as a vaccine. All right, you inject that into a person, let's say. Now that protein is going to trigger an immune response. All right, so your immune system's going to recognize that viral protein. It's not a virus, it's just a protein of the virus. And that's going to cause an immune response. You're going to build up um, all these antibodies, all this. You're going to kind of get resistant to. It's going to build up antibodies, protection for your body, right? So if you ever do get infected with the actual virus, your body's ready to go to defend. So the short of it is gene splicing. This kind of thing is used to make insulin, and vaccines are probably your two most common answers. All right, when you're trying to mass produce proteins, those are the reasons why: insulin and vaccines. That technique is called gene splicing.